Hello and welcome. In this explainer, we're going to get into one of the most important concepts in C programming, data types. You can really think of them as the absolute foundation that pretty much all programs are built on. Okay, let's dive right in.
So let's start with a really simple question. When you type the number 5 or the letter A into a program, how does the computer have any idea what to do with it? How does it know that you can do math with the 5, but you can't really do math with the A? Well, the answer to that question is all about data types.
So what is a data type? It's basically a label. It's a classification that you give to a piece of data. And that label tells the C compiler exactly what kind of information it's looking at and how it's allowed to be used. It's like you're telling the computer, hey, this thing right here is an integer, so you can add it and subtract it. Or this other thing is a character, so just treat it like text. It's really the rule book for all of your data.
Now in C, pretty much everything is built on just a few simple foundational data types. These are your basic building blocks, kind of like the raw materials you're going to use to build much more complex and interesting programs. So let's take a look at what they are.
Okay, here are the 4 foundational data types in C. First up is char, which is used for a single character, like the letter A. Then you have int, and that's for whole numbers. And then you have float and double. Both of these are for numbers that have decimal points. Now, the big difference between a float and a double is really all about precision. A double uses twice the memory, which lets it store a much wider range of numbers with way more accuracy. This is super important for things like scientific or financial calculations, where even a tiny little rounding error could cause big problems. And one more interesting thing on this slide is that column for typical size. These sizes aren't actually set in stone. They can change depending on the computer you're using.
So talking about this in theory is one thing, but how can we actually check these sizes on our own computer? Well, C actually gives us a built-in tool to do exactly that.
To find this out for ourselves, C gives us a special tool called the size of operator. Let's look at a complete program that uses it. First, you see #include studio H. That just pulls in the standard library we need for input and output, like the printf function. Then inside our main function, which is where every C program starts, we have 4 lines that do all the work. Each one uses printf to display some text. That %lu you see is a format specifier. It's just a placeholder for a long unsigned integer, which happens to be the type of number that sizeoff gives back. We then call sizeoff for each of our basic types: char, int, float, and double. The operator measures how much memory that type uses, and printf just slots that number right into our string. Let's see what happens when we run it.
And when you compile and run that code, you're going to see an output that looks just like this. This shows you exactly how sizeof gives you a clear, hard number for how much memory is being used on your specific machine. Now, your output might look a little different. Maybe your int or double has a different size, and that's totally fine. It just means the architecture of your computer is a little different. Okay, so now we know how to store different kinds of data. The next logical step is learning how to show it to the user in a clear way. Just printing raw data isn't always enough. We really need to control its format. And this is where format specifiers come in. In that last example, we used %lu because that's what the size of operator returns. These are special codes you put inside functions like printf to tell them what kind of data to expect. So using %d for an integer or %f for a float makes sure that the value is displayed correctly. It's kind of like you're telling printf how to translate the raw bytes of your variable into text that a human can actually read. Along with format specifiers, we also have something called escape characters. These are little commands that control the layout of your text. The one you'll see all the time is /n, which you've already seen in our examples. It just creates a new line, which keeps your output clean and easy to read. You can also use others, like /t to add a tab or /double quote if you actually need to print a double quote mark. It all gives you very precise control over how your output looks. Okay, so we've covered data types, the size of operator, format specifiers, and escape characters. Now let's put it all together and build something practical, a simple body mass index, or BMI, calculator. So before we jump into the code, let's just quickly define what we're doing. BMI is a measure of body fat, and it's based on your weight in kilograms and your height in meters. The formula is really simple. You just take the weight and divide it by the height squared. This is the logic that we're about to translate into C code. So here's our game plan. First, we're going to declare some variables to hold the weight, the height, and of course, the final BMI result. Next, we'll ask the user to enter their data. After we get that, we'll apply the formula to make the calculation. And finally, we'll print the calculated BMI back to the user. It's a simple 4-step process. All right, here it is, the complete program that puts all of these concepts together. Let's walk through it. At the top, right after including our standard library, we declare 3 variables of type float: weight, height, and BMI. We're choosing float here because these numbers are almost definitely going to have decimals. Next, we have a pair of printf and scanf functions. The printf just displays a prompt, asking the user for their weight. Then, scanf stops and waits for the user to type a number. The %f tells scanf to expect a float, and that and wait part tells it exactly where in memory to store that number. We do this exact same thing again for the height. Then comes the most important part, the calculation. BMI equals weight divided by height times height. This is just a direct translation of the formula into C code. Finally, we use printf one last time to show the result. And notice the point 2f? That's a really handy trick. It's a format specifier that tells printf to print a float, but to only show 2 digits after the decimal point. This gives us a really nice, clean output. So when you actually run the program, the whole interaction will look just like this. The program asks for input, the user types it in, and the final, nicely formatted result is displayed. This really shows how all the pieces we've been talking about, data types, getting user input, doing a calculation, and formatted output, all come together to create a genuinely useful little application. So we've gone over the fundamentals, and we've built a working program. Now it's your turn to get some hands-on practice and apply what you've learned. Here's your challenge. Take the BMI calculator that we just built and modify it. Instead of asking for kilograms and meters, can you make it accept weight in pounds and height in inches? You'll need to look up the conversion formulas and then work them into the program's logic. This is a fantastic way to really make sure you understand variables, data types, and calculations. Good luck.